Suppose we have the following problem. Drug is eliminated from the body through urine exponentially, meaning following an exponential decay. This happens if a drug is eliminated at a constant rate, for example, which is a very reasonable assumption. Suppose a dosage of 50 grams initially shows that 30 grams are eliminated after 8 hours. Express the drug concentration in the body after t hours. So this is a very standard problem in exponential word problems. You have two data points and you need to find the expression for the quantity at any time. So because the behavior is exponential, we know that our q of t, which we denote drug at time t, so we know that at 0 we have 50 grams, and we also know that after 8 hours 30 grams are eliminated, which means that 20 grams are left in the body. Okay, so this is a little bit twist of the normal thing. So with two data points like this, we can find the value of the unknown constants in the exponential law. The exponential law here is q of t equals c times e to the at, and we need to find c and a. So we will plug in 0 and 8 for t. So we will have c times e to the power a times 0 equals 50, from which we get c times 1 equals 50, because e to the a times 0 is e to the 0, which is 1. So we get that c is 50. We already know this because the constant c has interpretation as initial value in general. Initial value. Now let's plug in t equals 8 in the exponential law. So we have c times e to the a times 8 equals 20. We plug in the known value of c in this. So we have 50 times e to the a times 8 equals 20. Divide by 50. So you get e 8a, e to the power 8a equals 2 over 5, which is 0.4. Take ln, so ln e to the 8a equals ln of 0.4. The logarithm and the exponential cancel each other out, and we left with 8a equals ln of 0.4. A equals to ln 0.4 divided by 8. So we have found both c and a. So we know what the q of t is equal to. It is 50 times e to the ln 0.4 divided by 8 times t. Note, ln of 0.4 divided by 8 is not equal to ln of 0.4 divided by 8. You cannot just bring in the constant inside the logarithm like this. This is a common mistake, but please resist. Okay, so this was part A. Now part B, find the half-life of the drug. So half-life is the time it takes for the quantity to half in value. It's a certain time it takes to half the quantity, a certain quantity that decreases exponentially. So if this is a time t, then we have that q at time t is half, so one half times the initial quantity q of 0. So if we now plug in the expression for q of t, we have this equation. Now c and c cancel each other because we can divide both sides of the equation by c. And then we take ln e to the power, exponential and logarithm cancel each other out, and we have a times t equals ln of 1/2. ln of 1/2 is also negative ln of 2. So t is equal to negative ln of 2 divided by a. So giving half-life is equivalent to giving the constant a. We can just plug in the a that we found in part A to find the half-life. So this is negative ln 2 divided by ln 0.4 divided by 8, which is negative 8 ln 2 divided by ln 0.4. And that's the final answer. That's the half-life of the drug in the body. And we can also sorry about this. We can also check whether this is a reasonable answer, because what we expect the half-life to be is slightly less than 8 hours, because more than half of the drug is eliminated after 8 hours. So half the drug is eliminated somewhere before 8 hours. It's always good to check your answer against common sense. So part C asks how long till the drug reaches its minimum efficiency of 10 grams. So part C is asking which time is such that Q of t is equal to 10. So we plug in expression for Q of t, which is 50 times e to the ln 0.4 divided by 8 times t equals to 10. And we are solving this exponential equation. We have to divide by 50 on both sides. So we get e to the ln 0.4 divided by 8 times t equals ln of 1/5. Then we take, so this is equal to 1/5. We haven't taken the ln yet, but now we take ln 0.4 over 8 times t equals ln 1/5. ln exponential go away, and we are left with ln 0.4. ln 0.4 over 8 times t equals ln 1/5. So that means t is equal to ln 1/5 divided by ln 0.4 divided by 8. And that's the final answer.